Hi there. Welcome to this lesson on the coordinate plane and horizontal and vertical lines. Please like this video and subscribe if you find this video helpful, or drop me a comment or question below. Let me know what you think of this lesson or what you'd like to see next. Now, if you've been following these lessons in order and you've been looking at the Algebra 1 content, then you know we've already looked at the number line and we've really used the number line as a mental or visual model for operating with sign numbers. Now, sorry about the marks there. Like I did them on an earlier take and I can't get them to go away, which is really weird. So let's hope that doesn't continue. But if you were to see x is equal to 2, one way you could represent it graphically would be to simply plot it on the number. And so you could come over here and just plot a dot at x equals 2. And that's not an unimportant idea because we get to the idea of when we're dealing with graphs, what we're doing is we're shading or coloring in the solutions. So if x is equal to 2, then you represent that solution by literally coloring in the 2. And the way you do that is by putting a dot at the 2 and making sure that that dot is colored in like so. This is one variable math, and we can represent it in one dimension on the number line. So the number line is one dimension. It's got this length going on. That's its one dimension. And if you only have one variable x, then you can represent it on the number line. And typically the horizontal number line is called the x-axis. But much of math deals with two variables. In fact, I would say maybe more than half of what we do, we're dealing with more than one variable. Sometimes we'll even have 3 variables or 4 variables. The worst problem I think I've ever seen had something like 7, and it was a physics problem with a volleyball net. But most of the time we're in 2. So one way of conceptualizing math is to see it as the study of relationships. That is how one set of numbers is related to another set of numbers. So you've got one set of numbers, say time, 1 hour, 2 hours, 3 hours, 4 hours, something like that. And then another set of variables. And those two variables are related to each other. So here are some examples. Height depends on age, at least in childhood. Okay, we'll come back and look at that at the end of this lesson. But as your age increases, so does your height. And so if you saw like a 6-foot 4-year-old, you would say that is not right. Because we grow as we age, at least in childhood, okay? Distance traveled depends on the time. So you've got one set of variables, that is your time. So again, I've been traveling 1 hour, 2 hours. A friend of mine was traveling to North Carolina yesterday, and so the amount of distance that she had traveled depended on how long she had been traveling. Money earned depends on hours worked. So if you get hired to do a job and you get paid a certain amount per hour, then the money that is in your paycheck will depend on the number of hours worked. So one set of variables here would be age, and the other set of variables would be height, and they are dependent on each other. You could have time and distance, or maybe time, hours worked, and money, etc. And there's tons and tons of things that are related to each other. Time is a really, really common one. We just see a lot depends on time, but not everything. So here we have like height and age, although I guess age is another way of measuring time, so to speak. But we have these two variables, and those two variables are related to each other. Now, this introduces the need for more than one number line. And what we have here is, and there'll be some notes coming up on the right, is a number line going left and right. And then we have another number line intersecting it, going up and down, and they intersect at the zeros. Now, as you move further in math, particularly in your science classes, you can sometimes end up messing with this a little bit, sliding the one or the other axis like back and forth a little bit, but that is not where we start, and honestly is not that common either. So we have those two number lines. 2 axes, so they are called axes. The singular is axis and plural is axes. The x-axis is the horizontal one. So you'll often see like a little X there, and the y-axis is the vertical one, so you'll often see a Y. You will sometimes see this, and we are not going to talk about that in this lesson, but if you do see like f of x is how you read that, just know we're talking about the same thing, okay? So the y-axis is the vertical axis. This plane, okay, Okay, so now if you haven't done geometry yet, you probably haven't studied planes, but planes are two-dimensional surfaces. So as opposed to one dimension, which would be just the number line, now we have two dimensions. So we have two number lines, and that gives us a plane. We'll often hear this called the XY plane. Named after the two axes. You'll hear it called the Cartesian plane or Cartesian coordinate system, and that is after René Descartes, who is responsible for a lot of the math that we study. So famous historical mathematician, go ahead and look him up. You'll also hear the coordinate plane because what we do with this is we map different coordinates. So we can, those are the three most common names for that plane. Now, we can sometimes get lazy and we call this a graph, but the graph is actually what we put on the plane. Just be mindful of this and how you speak and how you hear what others are saying. We just get lazy about it, and I've caught myself doing it where I'll tell my students, hey, sketch a graph. And what I mean when I say sketch a graph is put the X and Y axes on in your notebook or whatever we're doing, like put them on the whiteboard. And really, that is not correct. The graph is the thing that we put on this plane, but this is the XY plane or the Cartesian plane or the coordinate plane. So I try not to do it in my own classroom, but it is hard to avoid the laziness sometimes. It's just easier to say it, and most of us know what we mean. So just something to be mindful of with the vocabulary use. Now, the coordinate plane gives us a way to picture these relationships between numbers. One set of numbers is plotted on each number line. So let's say you're talking about age and height. So you might put age on the x-axis. So the numbers on the x-axis represent age. Now, if you look at this one where my pointer is hovering, it doesn't make any sense to say that somebody's like -4 years old. And so we would say that those numbers are not in the domain, another math concept, but basically they don't mean anything in that context. So the youngest you can be is 0, and then we go upward from there. And then your height could be graphed on the y-axis. And so, you start with probably not 0 height, but I don't know if we're doing it in feet. Yeah, you can scale that, however. But basically, you got age on one axis and height on the other axis. And now we have a way of visualizing that relationship. Locations on the coordinate plane are represented by ordered pairs. So my students often get this confused. So ordered pairs is how we represent a location, and the location is called a point. Pair means two. Ordered means that the order of the numbers matters. So when we go to graph these, we have a set of parentheses, and then we have these two numbers, and they're separated by a comma. The first number represents where we are on the x-axis. The second number represents where we are on the y-axis, and you cannot just decide to do that the other way. The order matters. So if you decide you're going to do yx instead, I guess go for it, but you'll be the only person in the world doing it and you'll get all your problems wrong. So do not recommend. When you are determining the location of a point on the coordinate plane, you do need to give both numbers. And that's something that I have seen a lot of mistakes with, where I'll say, give me the point, and a student will give me one of the two coordinates. So for example, the point -2, 3 means this. We are at -2 on the x-axis and 3 on the y-axis. So to plot that, we would go over to the -2 on the x-axis and then up to the 3. And so what we're looking at there is that location or that point. And then we would plot that point by putting a dot there. Okay, and that's plotting the point. The next one. We have 0 on the x-axis and -3 on the y-axis. And I think the graphic for my plane there just obliterated some of my parentheses. So for that one, we are at 0 on the x-axis, which means we're going to be dead center. And then we would go down to -3. So that would be that location there. And we would plot that with a dot. And then the point 3,5. It means we go 3 on the x-axis and then up 5 on the y-axis. So we would be here, and we'll grab the purple. 3, 1, 2, 3, 4, 5, right there. Okay, and that's what it is to plot points. And hopefully you've done that. I think that is covered in pre-algebra to some extent. I remember when I taught pre-algebra, giving my students activities to do, and they would plot all the points. And when you connected the dots, it would be a bunny rabbit or something like that, just to get that practice plotting the points there. So that's what it is to plot points. When you are asked for a point, you are asked for the X and the Y, not just the X or the Y. So now let's go back to our original problem. Suppose you see x equals 2 and you need to graph it in 2 dimensions. So in 1 dimension, you would simply go over to x equals 2 and you put your dot there. But if you were asked to graph this in 2 dimensions, it means that now you have to consider the y coordinates as well. And the way we do that is by graphing a vertical line, which is really poorly done there, I apologize, through the point x equals -2. Now, what we're doing there is we're actually finding all of the points where x is equal to 2. Okay, so if we were to look at the coordinates at all of those points have an x coordinate of 2. So this point up here would be the point 2, 8. This point here is 2, 7. And we connect them because even though they don't all have graph lines or like tick marks, grid lines there, there's points in between. So right there, that would be the point 2, 4.5. So all of those points have an x coordinate of 2 and the y coordinate doesn't matter. So basically we're plotting all the points where x equals 2, the value of y does not matter. Now what about y is equal to 4? So we can do this in a similar way. We would look at the y-axis and we'd look at where y is 4. But if we are asked to plot this in 2 dimensions, then we want all of the points where y is equal to 4, and that would graph as a horizontal line. Every single point on that line, y is equal to 4. So this would be the point, where am I over there? -6, 4. This is the point -3, 4. This is the point 5, 4. And you'll notice that every single point on that line, y is equal to 4. So that's the idea behind graphing horizontal and vertical lines. You think about all of the points where that particular coordinate would hold. So we are plotting all the points where y is equal to 4 and the value of x does not matter. We just want all the points where y is equal to 4. Now, here you can write the equations of the horizontal and vertical lines going through the point 4, -1. Now, I would do this without graphing it, but if this is new content to you, then we really want to reinforce everything. So the point 4, -1, your x value is 4, your y value is -1. So we go over to 4 and down -1. So we're talking about that location right there. And what we're being asked for is the horizontal line going through that. And on the horizontal line, every single y coordinate would be -1. And so the equation for that would be y equals -1. And we're also asked for the equation of the vertical line going through that point. And we'll notice that on this line, every single x coordinate is equal to 4. And so the vertical line would be x is equal to 4. Now, a lot of students do end up getting this confused because you think horizontal. Let me label that. That is the horizontal, and you think, oh, well, the x-axis is horizontal, but the equation of a horizontal line begins with the y. And then you might think, oh, but the vertical axis is the y-axis, therefore my line should start with y equals, but it's not. A vertical line, you're holding the x coordinate constant. And so your vertical line equations start with x equals. Just a little something to be mindful of because it is a common spot where mistakes are made. Now, here's one where you've got two equations and you're asked, or two graphs, and you're asked to write the equation from them. So looking at this, here's our horizontal line, and we kind of want to notice, well, what's that consistent thing that's like held the same everywhere in that line? And everywhere in that line, the y coordinate is equal to -7. So the horizontal line, the y coordinate is -7. Over here, we have a vertical line. And we're looking for what's the thing that's the same over there. And that vertical line, the thing that's held the same is that x is equal to -3. Every single point on that line will have an x coordinate of -3. Every single point on this red line here has a y coordinate of -7. So if you're looking at the lines, that's how you would write the equation. This will become very, very important much, much later in your study of algebra when you are looking for the equations of horizontal and vertical asymptotes, which is such a fantastic vocab word. But you'll need to be able to look at a graph and write the equation for it. So where might we see this in real life? Consider the graph below that shows the general relationship between height and age. So we talked about this at the beginning of the lesson. So when you're born, now notice that when I did this graph, I took off the negative numbers. And that's because in the context of age and height, negative numbers don't actually mean anything. So from the time you were born to maybe like looking at where this is, this looks like this might be around the age of 14 or so. You're going to grow. Now, you don't necessarily grow at a constant rate like that. So there are things called growth spurts where you might grow a little bit faster. But let's just say, for the sake of simplicity, that between the time you were born to somewhere in your teenage years, it'll be a little bit different for everybody, you grow. And then you hit your adult height. So height is generally horizontal after a certain age. I hit my adult height in about the 6th grade. I was very, very tall for a 6th grader, but as an adult, I'm a very average height. And since that time, like I don't grow anymore. Now, you want to get interesting about this, as you get older, this line might begin to tilt down a little bit. But here's where we see a horizontal line. Now, this kind of graph is called a piecewise graph because it has more than one piece. So there's a piece of the graph over here that's tilting up, and then this piece here that is horizontal. And so if you see a graph like that that kind of comes in chunks, it is called a piecewise graph. Don't forget, if you found this video helpful, give it a like and subscribe to the channel for more math content. Check out the link to the practice set for this lesson and drop a comment below and let me know what you'd like to see. I'll see you in the next one.